Hi, hello everyone. So this is the video dealing with section 6.2, law of cosines. This is the only video associated with this section. Its section is very small. And in this topic, it's a continuation from 6.1, which is the law of sines. And the law of cosines is needed under special circumstances. So it's just another relationship on the sides and angles of a triangle, specifically a oblique triangle. So an oblique triangle is just a triangle that doesn't have a 90-degree angle, right? So something that looks like this, for example, okay? And the law of cosines is going to help us solve two types of problems. So here's the first one. So in situations where we have a triangle, when uh, we only have either two sides and one angle, or the second case in which we only have three sides. Okay? Now, the only reason we need the law of cosines, and now I'll remind you here about the law of sines again. In fact, I'm going to show you right now. So here are both law of cosines and the law of sines. So you remember covering law of sines. The law of sines is perfect when we have a situation in which we have one side, for example, such as A, and we have the sine, we have the angle associated with that side. When we do, then we have a whole relationship, A over sine A, or B over sine B, or C over sine C, and then we can solve for the remaining values. Now, it so happens that sometimes, for example, take a look at my triangle picture here, we may have, let's say, this side, which is case one here. We may have side C, we may have side A, and then we may have angle B. All right, so in this situation, we cannot use the law of sines. Or another scenario is like the second case, we are given only the three sides. So in that case, we need the law of sines. And our purpose is usually to solve the triangle. So what we mean in mathematics when we say solve the triangle, it is to find all of the sides and all of the angles. Okay. There may be some cases where the information that we're given does not produce a triangle because maybe the triangle doesn't close because the measurements uh, doesn't produce a triangle. Okay, but by and large, the examples that we're going to see here, we're going to be able to solve it. Okay, so the approach is usually, you don't have to do it that way, but this is one usual approach, is that if we are given, for example, let's say three sides, we'll use the law of cosines to find one of the angles. Usually, what I recommend is find the angle opposite to the largest side. Okay, because you remember one of the properties of a triangle is the largest angle is opposite to the largest side because it makes perfect sense. So once we have that side and the angle associated with it, we go to the law of sines and then we find the remaining values. Okay, so the same goes for in the case where you were given three sides, right? You're given three sides. So use the law of cosines to find the largest angle. Or if you're given two sides and one angle, use the law of cosines to find the side opposite to that angle, and then go to the law of sines. So this is usually going to be my approach here, and it's very easy that way. And we'll see a couple problems. We'll see two problems in one application problem dealing with this topic, the law of cosine. So let's see the first one. And I'll make it a little bit smaller so that we can see the law of cosines and the law of sines at the same time. And I'll move this up here. These are the other two problems that we're going to see. Okay. All right, so let's see if this is enough space for us. So here's example one taken from the book as is. So you can, after the video, you can take a look at the example that's worked out in the textbook. All right, so the question is solve the triangle with, by the way, let me just mention this. Take a look at the law of cosines. Um, in capital letters, we have the angles, A, B, and C on a oblique triangle. So all of the capital letters are the angles. All of the lowercase letters are the sides. So it kind of looks like the Pythagorean theorem, which it kind of is, but on an oblique triangle. So to find the side of A, we're going to need the cosine of the angle A. To find the side B, we're going to need the cosine of the angle B. To find C, cosine of the angle C. So the formulas are pretty easy. You don't have to memorize them. I'll give them to you on an exam. But this is the format. All right, so now let's see what we have here, what kind of a triangle we have. So we are given, we have to solve the triangle whose angle A is 60 degrees, sine B, and side C. So this is a situation, this is the first type of problem that we are given where we have angle A, but we don't have side A. And we are given side B, and we're given side C. So this is a perfect case for the law of cosines. And now it's easy to see which of the three formulas we have to use. Okay? So we have to use the first formula because we have the angle, A. So I'm going to write it here. A squared equals B squared plus C squared minus 2 times BC times cosine of angle A. And I will find the value of A. So let's see, A squared equals, the side B is 20, so B squared is 20 squared, right? Which is 400. And plus C squared is 30 squared, which is 900 minus 2 times B, which is 20, times C, which is 30, times cosine of the angle A, which is 60 degrees. All right, so A squared is, I can add these two values. And this is going to be 2 times 20, 40 times 30. So this is 40 times 30 is 1200. You can do this on a calculator, cosine of 60, which is 0.5. And now I have the A squared is 1300 minus 1200 times 0.5 is obviously 600. So I'm going to do it over here. Obviously 700. So now we take the square root of both sides, right? To find the value of A. So we can go to the calculator. And square root of 700, which is about 2645. 2645. I think I'm going to say 27 degrees. Okay. 27 degrees. You can say 26. Let's say 27. Okay, so let's see now. I'm going to use my picture over here. I have this angle and I also have this side now. I'm sorry. So I found the side. Yeah, so I made a mistake here. The A, small a, is not the angle, right? Is the side. So this is approximately 27. The angle A, this angle A is 60 degrees. All right, so just be careful. Let's not make a mistake here. So approximately 27, whatever units. They didn't give us the units. Okay, so 27 units. Okay, so now notice I have A, angle A, and I have side A, which means I can use the law of sines. All right. I have A and I have sine A. I have side B, and now I can find the capital angle B using the law of sines. So let's see. So I'm going to use this part of the law of sines to find the angle B. Okay. Notice that you could have also used the second formula of the law of cosines to find the angle B. All right. It's also possible, but I have a feeling that the law of sines is a little bit easier, and I can cross multiply. So I think it's going to be a little fast. So let's use the law of sines to find the angle B. Okay, so it's A over sine A. So A, I already know, approximately 27. Sine of A, which is 60 degrees, equals side B, which is given as 20, over sine of angle B, which we don't have. So I'm going to cross multiply, and I end up with 27 times sine of B equals 20 times sine of 60. And then I'm going to divide both sides by 27. Okay, when I do, obviously these two 27s get out, are canceled, and I'm left with this. So I need to evaluate this thing right here. So that I'm going to do it on the calculator, obviously. So let's see. So 20 times sine of 60 degrees divided by 27. So we get 0.6415. And now I have that sine of B is equal to this value. Now remember how we solve this? This is the inverse property, right? So B is sine inverse of 0.6415. And obviously I need the calculator for that as well. So I'm going to say second sine for sine inverse, 0.6415, and that should give me the angle, the B angle. So 39.9, so I'm going to say approximately 40 degrees. All right. All right, so let's see what we have so far. So I have that this is 60. I found out that this is approximately 27. I already know what B is. It was given to me as 20 down here. All right, so here is B and here is C. And already found B, angle B. Obviously, keep in mind that this triangle that I have right here, it's not the same triangle as this. This is a generic picture of an oblique triangle. So the figures, obviously, you can see that 60 degrees is bigger than 40, but angle B here is bigger, right? It's okay. This triangle is not for my picture. It's just to show you what we have and what we need to find. So it seems like the only thing left that we need to find is this angle C. Well, how do I do that? Do I need to apply the law of cosines or the law of sines? No, I don't need to do that anymore. Here's the reason why. So you recall that the sum of the internal angles of a triangle is 180 degrees. So I can use that fact to find C, right? So I know that angle, I'm sorry, the angle A plus angle B plus angle C is 180 degrees. I already know what A is, and I already know what B is. So the two add up to 100, right? 60 plus 40. Obviously, I'm rounding. Um, Subtract 100 from both sides, and we get that C is 80 degrees. Now, it is advisable that you confirm that these values are okay with the values that you were given. Okay, so notice that the largest side is 30, which means the largest angle has to be capital C. Okay, always check to see if the largest angle is associated with the largest side. In this case, it is. So we solved the triangle. We found that the angle A was 60. We found that the angle C was 80. And we found that sine small a was 27. And we solved the triangle. So this is how you use the law of cosines to solve uh, these triangles. So this is the first example, right? The second example is very, very similar. I'm going to erase all of this so we can work on the second example. And I'm going to remove this thing from here to make a little bit of space. So I can make it a little bigger. And now make it smaller again so we can see the law of cosines and the law of sines. All right, so let's take a look at the second case. So here's the second example, right? In the second example, I have the second type of problem that the law of cosine solves, which is you are only given the sides. Okay, so now I have A, B, and C, and you begin by finding one of the angles. Now, this is what I suggest. Notice that B is the largest side, right, with 9, which means that And by the way, so this example here kind of fits a little bit our triangle. Not necessarily identical, but side B, which is the largest side, is associated obviously with the largest angle, which matches our picture up to this point. Okay. So I suggest you begin finding the angle when you have a situation where you're given three sides. I suggest you find the angle associated with the largest side, which in this case is capital angle B. So then you go to the law of cosines and find which formula has the angle that you're trying to solve for, which is the second one. So it's my B squared. So I'm going to write that formula here. B squared equals A squared plus C squared minus 2AC times cosine capital B. And let's do the exact same thing as we did before. I know what sides A, B, and C are. So B squared is 9 squared, which is 81. A squared is 6 squared, which is 36. And C squared, which is 4 squared, 16, minus 2 times A, 2 times 6 times C times cosine of capital B. All right. So I'm going to add these two, right? So 36, 46, 52, 52 minus this is 6 times 2, 12 times 4, 48 cosine capital B. I'm going to subtract 52 on both sides. Right? And these will cancel, and I end up with 29 over here minus 48 cosine capital B. Right? So now I'm going to divide both sides by 48. They will cancel here. In fact, I'm going to divide it by minus 48 both sides. So now this is what I have. Obviously, this is going to be a negative answer. So I have that cosine capital B equals negative 29 over 48. Now, how do I solve for the angle B? It's the inverse function again. So cosine inverse minus 49, 48. Now, you don't need to know, but because cosine is negative, the angle is on the second quadrant. So the angle is going to be bigger than 90 degrees. Okay? But you don't need to know that. You just go to the calculator and we are going to find the cosine inverse of minus. Now, don't type in the operation minus, okay? It's the symbol minus right here, the negative sign. 29 divided by 48, and my answer has to be a value greater than 90 degrees. All right, so here it is, 127.16. I'm going to approximate it to 127, okay? So 127 degrees. So I found one angle. So I found this angle, and now I have all three sides. All I have to do is to solve this triangle, I need to find two more angles. And I'm going to use now, I could use the law of sines, for example, I'm sorry, the law of cosines, this formula to find the angle A, but I suspect it is easier to use the law of sines, because the formula is a little bit easier. Okay. So I'm going to use, and just to make things different, I'm going to try to find the angle C, okay, using this formula. So I have one complete fraction with A over sine of A, and I want C over sine of C. So I'm just going to erase this a little bit. So B, I already know it's 127 degrees. And now I'm going to use A sine A and C sine C to find the angle C. All right, so I know what A is. It was given to me as 6. And sine of 100 and actually I don't have sine of A. So I cannot use that. Okay. I need to use the one with the information that I have. So very good. So we made a mistake. We fix it. So I can't use this part because I don't have angle A. I do have angle B. So B over sine of B. Yes, this is the correct fraction or relationship that I need to use. So I have B, which is 9, and I have sine of B. Sine of B is the angle B, which is 127. Equals C, I have C, which is 4, divided by sine of C that I want to find. And now we cross multiply as we did before. So I have 9, cross multiply, 9 sine of C equals 4 times sine of 127. Divide both sides by 9. They will cross here. And now I have that sine of C is this, which I need to evaluate with the calculator. Okay. So I'm going to do 4 times sine of 127 divided by 9. And this is 3549. So 0.3549. And again, how do I find the angle C? Well, by the inverse property, right? So sine inverse 0.3549. And again, I go to the calculator for this. So second sine inverse 0.3549, and that should give me the approximate angle 20.78. I'm going to say this is approximately 21 degrees. Okay. All right. Now we already have almost everything, right? I have angle B. I had all three sides to begin with. I already found angle B, 127. I already found angle C. All I need to do now is find angle A. Now, I could use the law of sines. I could use the law of cosines, but I don't really need to, right? I know that the sum of the angles is 180 degrees. So A plus B plus C is 180, and I know that B plus C is 127 plus 121, which is 148. So just subtract 148 from both sides. And we get that A is approximately 32 degrees. Okay, so we now found everything that we wanted, all of the sides, all of the angles, and this triangle is solved. Okay, so applying the law of cosines and the law of sines to solve the triangle. Okay, so last problem is an application problem. I'm going to erase all of this. So let's solve an application problem. So sometimes the application problem are the easier ones because we don't have to find every piece of information. We just have to find what we are asked to find. Okay, so I'm going to move it here. Just move it here. And I'll make it a little bit bigger so that we can be able to see the both law of sines and cosines. Okay, so here's the problem. Again, this is taken from the textbook, so you can see the problem being worked out later. So this is an applied problem using the law of cosines. Okay. Now, if I give you a question like this on the exam, I obviously will give you a picture because sometimes without the picture, it may be a little complicated for some of you to do. I'll give you the picture. Okay, so here's the problem. So two airplanes leave an airport at the same time on different runways, in very likely different directions. One flies bearing of north 66 west at 325 miles per hour, and the other flies bearing south 26 west, 300 miles per hour. So this is the situation that we have. All right, so just bear with me because this is hard to do it with this thing. So obviously, you know, north, south, east, and west. So one plane flies this way, and the angle here is, they said, where is it? North 66 west. So this is 66 degrees, and it's going 325 miles per hour. The other one is going south, going down, 26 west. So west is here, so I'm 26 degrees going into that direction. Okay. 300 miles per hour. So here's the question that we have to solve or find the answer to. We don't need to solve the triangle. We don't even see the triangle yet, but you will soon. So how far apart will the planes be after 2 hours? So this is plane one going into this direction. Here's the second plane. So notice that their distance apart is a triangle, right? Here's the triangle. Okay. And now I'm going to transcribe this information over here. Here's the triangle. All right, so I'm going to call this side A, and I'm going to call this side B. Okay, you can call it whatever you want, which means that this is C. Okay, which means that this is capital C, this is capital A, this is capital B. Your lettering could be different. Now, I have this angle. I have this angle. How do I find this angle right here? How do I find that angle? Well, we know that if I have a line, the angle from here to here is 180 degrees, right? Of which I've already used 66 plus 26. So this angle here, right, that angle here is 180 degrees minus 66 plus 26. Now let's see what that is equal to. You can do it in your head. You can do it on the calculator. I'm going to do it on the calculator. 180 minus 66 plus 26, which is 88. Okay, so this angle here is 88 degrees, which is perfect because now all I have to do is I need to find how far apart are they. So this is the distance I have to find. So I need to find side C. Okay, so here's the formula. Well, Professor, but what if I use the different letter? That's okay. If you use the different letter, you're going to use one of the other two formulas. It doesn't matter. It's going to work out the exact same way. And you can try it if you want to. All right, so in my case, I call this side C. I need to find lower C, the side. Well, let's see how we can do that. And we obviously going to do it using that last formula on the law of cosines. So here we go. So C squared equals A squared plus B squared minus 2AB times cosine of C. All right, so let's see what we have. I need to find C, which is perfect. I have capital C, 88. But what is A and B? All right, so we have to go back to the problem because maybe we're missing some information. Okay, so the problem says, so let me just erase this a little bit. So the problem says that one plane flies 325 miles per hour, the other 300. And they want to know how far apart are the planes after 2 hours. So if the first plane is going 325 miles an hour for 2 hours, we just multiply the two, right? 650 miles is A. The other one is going 300 miles per hour for 2 hours, obviously 600 miles. So B is 600 miles. So now I have A and B. Okay, so let's see. So C squared equals A, which is 650 square, plus B, which is 600 square, minus 2 times A, which is 650, times B, which is 600, times cosine of 88 degrees. So notice I have every single thing in here. So I just need to do this very carefully on the calculator. Okay, so I'm going to enter all of these values all at once. So 650 square plus 600 square minus 2 times 650 times 600 times cosine of 88. And that is this gigantic number right here. I'm going to write it over here. 9777 9777 9777.83. Okay. And now I'm just going to take the square root of that number. So square root of 7797.83. And we get approximately 883. 883. And what are the units? So the C is a distance. So this is in miles. So C is approximately 883 miles. Okay, so the application was even easier than, solving the triangle where we have to find all of the sides and all of the angles. Okay, so this is the law of cosines. So we need it when we do not have a complete relationship like we have in the law of sines. And usually these problems begin by we do one application of the law of cosines, and then we can go immediately to the law of sines and find the other values. And at the end, sometimes we use the fact that the sum of the internal angles of a triangle is 180 degrees to find the remaining angle of the triangle. So this is, in essence, the application of the law of cosines.